Combining transformations. When combining transformations, it is very important to consider the order of the transformations. For example, vertically shifting by 3 and then vertically stretching by 2 does not create the same graph as vertically stretching by 2 then vertically shifting by 3. When we see an expression like 2 times f of x plus 3, which transformation should we start with? The answer here follows nicely from order of operations for outside transformations. Given the output value of f of x, we first multiply by 2, causing the vertical stretch, then add 3, causing the vertical shift. Multiplication before addition. Combining vertical transformations. When combining vertical transformations written in the form a times f of x plus k, first vertically stretch by a, then vertically shift by k. Horizontal transformations are a little trickier to think about. When we write g of x equals f of 2x plus 3, for example, we have to think about how the inputs to the g function relate to the inputs to the f function. Suppose we know f of 7 equals 12. What input to g would produce that output? In other words, what value of x will allow g of x equals f of 2x plus 3 equals f of 12? We would need 2x plus 3 equals 12. To solve for x, we would first subtract 3, resulting in horizontal shift, then divide by 2, causing a horizontal compression. Combining horizontal transformations. When combining horizontal transformations written in the form f of bx plus p, first horizontally shift by p, then horizontally stretch by 1 over b. This format ends up being very difficult to work with, since it is usually much easier to horizontally stretch a graph before shifting. We can work around this by factoring inside the function. Factoring in this way allows us to horizontally stretch first, then shift horizontally. F of bx plus p equals f of b of x plus bp over b. Combining horizontal transformations, factored form. When combining horizontal transformations written in the form f of b of x plus h, first horizontally stretch by 1 over b, Then horizontally shift by h. Independence of horizontal and vertical transformations. Horizontal and vertical transformations are independent. It does not matter whether horizontal or vertical transformations are done first. Example 19. Given the table of values for the function f of x below, create a table of values for the function g of x equals 2 times f of 3x plus 1. Input x values are 6, 12, 18, 24. Output f of x values are 10, 14, 15, 17. There are 3 steps to this transformation, and we will work from the inside out. Starting with the horizontal transformations, f of 3x is a horizontal compression by 1 over 3, which means we multiply each x value by 1 over 3. Input x values are now 2, 4, 6, 8. Output values f of 3x are 10, 14, 15, 17. Looking now to the vertical transformations, we start with the vertical stretch, which will multiply the output values by 2. We apply this to the previous transformation. Input x values are 2, 4, 6, 8. Output values, 2 times f of 3x are 20, 28, 30, 34. Finally, we can apply the vertical shift, which will add 1 to all the output values. Input x values are 2, 4, 6, 8. Output values, g of x equals 2 times f of 3x plus 1 are 21, 29, 31, 35.